Let's talk about the decoder attention block. There are two attention blocks. First attention block, masked multi-head attention. We call it self-attention due to functional reason. Second attention block, multi-head attention. We call it cross attention block, definitely due to the functional reason. Suppose encoder module have token "How are you?" that after processing goes input to the decoder module and available for cross attention processing. Suppose the reply going to be generated is "I am fine," which is generated one by one. Let's look into the reply of the journey. In decoder module, we can see two inputs are there. Decoder input 1, that we can call as DI1. At the output shifted right, means over here there is a decoder input 1, and over here is decoder input 2, that comes from encoder module to decoder module. So these are the two input for the decoder module. So DI2 is a processed vector of token, and D1 is the empty at starting. DI1, decoder input 1, is empty at the starting. So model introduces SOS, the start of the token by itself. Now let's look into the journey ahead. SOS moves from output to output embedding. Then it moves to positional encoding. We have already discussed in details what are they. So if you don't know what is going on here, please refer the previous video. Then from positional encoding, it moves to the multi-head attention, masked multi-head attention, that we also call it as self-attention. Means it is going to attend self-generated token. So as this is the start of the generation, so there is no token, and in the start of the token, model assumes it's as the start of the sequence SOS. So SOS is alone, it's moved forward to this attention block. This is the cross attention block. What this cross attention block did is attention of SOS gets calculated with the input coming from the encoder module. Here we take the example as "How are you?" So attention is calculated with that. Now the SOS moves to the feed forward, all the calculation, and again the same vector out from here, SOS vector. This SOS vector now multiply with the matrix that we call as projection matrix. The output is a multi-dimensional array of length, total number of tokens. So suppose this model has the total number of tokens is 30,000. This is the total number of tokens that is available for this model. From that only it is going to predict. So so after the last vector multiplied by the projection matrix, we get the array of 30,000 numbers that we call as logits. Then after this, it comes, after converting into the logits, it goes to the softmax layer and converted to the probability distribution. Onto the probability distribution, the token which has the highest number is the next predicted output over here. So after SOS, suppose it gets to predict I, because the question is "How are you?" and we suppose the answer is "I am fine." So first I gets predicted. So SOS input from here and predicted is I. Now again the output gets into the input. So previous input is SOS, new input is I. So now SOS and I goes through this positional, goes through this self attention. Now what happened over here is attention score gets calculated between SOS and I. Yeah, that's calculated. Then from here, two vector moves from here, cross attention. Now here SOS and I attention gets calculated with the input coming from the encoder module. As here we have the example, how are you? So that attention gets calculated. Now that vector goes from here into the feed forward and then output over here, right? So two vectors are there. So we take the latest vector, that is latest vector is of I, that we multiply the latest vector with the projection matrix. We get, in our example, 30,000 a multi-dimensional array with 30,000 with dimension 30,000, that we call as logits. So we get the logits over here, then it passes through the softmax and we get over here the probability distribution. Again we are going to select the highest probability over there. So highest probability, suppose the word of M. So now what we have now is SOS, I and M. As we have assumed, the answer should be I am fine. So now here what is the input? SOS, I am goes through here, goes through positional encoding, goes through masked multi-head attention, means self attention. So here there are three SOS, I am. So self attention between three gets calculated over here. Then these three vectors come over here, attention with the calculated over here with the encoder module, attends over here, then moves to the feed forward. Then the output is over here is three vectors, right? In three vectors, get the latest vector over here and then multiplied with the projection matrix, get the multi-dimensional vector with the length 30,000 token that we call as logits, and then logits pass through the softmax and output is probability distribution. We select the highest probability over here as our next predicted token, so that is fine. Okay, then here we get the answer, right? SOS, I am fine. Again pass it through here and moves through here as we have learned, and finally what it generates is EOS, end of sequence, and it shows that the process is going to stop over here when the model generates EOS, end of sequence, over here.